So this is the last topic in trig solving, and it will be trig inequalities. Now you will have access to a calculator for this portion, and I will reference the calculator in graphing, but I'm going to focus on non-calculator manipulations because I believe the questions on the AP pre-calculus exam are in the multiple choice non-calculator portion. So I want to try and stick to solving these without using technology. However, if you want to use one, you can to check your information. I think I used it in the class, but for this video, it's just going to be all non-calculator. And I'm a little sick, so I apologize if there's sniffling or coughing, but I'll try to keep it to a minimum. So in previous units, we solved inequalities of polynomial and rational functions. Similarly, we can solve inequalities involving trigonometric functions. So this first one, we see a sinusoidal curve. It is sine, but it doesn't matter which one it is. The graph of f is defined by negative 2 pi to 2 pi, both inclusive, as shown. What are all of the values of x for which f of x is less than or equal to 0? So the most important part of this question is going to be, what is the inequality, and is it inclusive or non-inclusive? This particular inequality is inclusive, and we want to know when will this curve be less than or equal to 0. So if I start on the left side, I can see that this first part of the curve is going to be positive because it's above y equals 0. So we'll call this y equals 0 here, or f of x is equal to 0. And then once we pass negative pi, we can see that it is below 0. So this is our threshold for what satisfies or dissatisfies this inequality here. So this next curve, we have it positive because it's above. And then the last part of the curve is going to be negative because it is below. So we want to focus on when is f of x less than or equal to 0. So I'm also going to include when it's equal to 0 by using solid filled in dots. And what I want to focus on is, this section here and this section here. This is the part of the curve, or these two parts or two intervals are the parts of the curve that satisfy the inequality. So f of x is negative and equal to 0 on, it starts at negative pi, it's inclusive, and the input being used is x, and then it equals 0 again at 0, or also it picks up again from pi is less than or equal to x, which is less than or equal to 2 pi. So remember, for inequalities, there's always one input that you want to select. It's not going to be an and. So we're going to select the next value from either the first interval or the second interval. Now this one is a pretty special case. If it was non-inclusive, we would just have the same intervals but make them non-inclusive, but we do have another point where it is equal to 0, and it's going to be over here at negative 2 pi. And because our domain restriction includes negative 2 pi, we'll also have to say or x is equal to negative 2 pi. I don't remember who it was in one of my classes. I actually missed this the first year I taught it, and then a student pointed it out in class, and yep, that was something that I missed. So make sure you check when it's actually equal to 0. Don't leave any solutions out. Number 9, what are the values of theta for 0 to 2 pi? So now 2 pi is non-inclusive, for which sine of theta is greater than or equal to the square root of 2 over 2. So we have sine theta is greater than or equal to the square root of 2 over 2. So what I want to start with is we are talking about a very particular interval on our unit circle. So we have our unit circle here. That is not a circle. Let's try this one. Okay, and I want to talk about the two angles where sine is equal to square root of 2 over 2. And that's going to be, actually it's splitting them in half here and here. So in quadrant 1, this is going to be theta is equal to pi over 4. And then in quadrant 2, this is theta is equal to 3 pi over 4. So this is basically asking when will y be greater than or equal to root 2 over 2? Well, if we think about y is going to be the vertical relationship here. It's going to be positive as we go up and then negative as we go down. And then in particular, we are looking at what values will be greater than square root of 2 over 2. And that's going to be this part of the unit circle here. Okay, so all of my thetas, or the thetas that will satisfy this inequality, will be from pi over 4 to 3 pi over 4. Because once we continue around the unit circle past 3 pi over 4, our y outputs, they become less than root 2 over 2. So the interval for this one will be pi over 4 is less than or equal to theta, which is less than or equal to 3 pi over 4. And I'm including them because it wants the interval for which it's greater than or equal to. Now, if you were to graph this in the calculator, you would have y1 is equal to sine theta, and then y2 would be equal to root 2 over 2. And essentially, you would want to graph from 0 to 2 pi. You'll have your sinusoidal curve. And then up here, if you graph the line root 2 over 2, you're going to see this. And then you would have your intersections at pi over 4 to 3 pi over 4. Because from 0 to 2 pi, this is the only part of the curve that will be greater than or equal to root 2 over 2. Now, obviously, if you plug it in, you're going to get a decimal form if you try to find those intersections, which is why, in my opinion, just sketching a unit circle, finding the portion of the unit circle that satisfies the inequality, and then using those angles that correspond with that portion. So number 10, let f of x equal 4 plus 2 cosine x, and let g of x equal 3. What are all values of x in the xy plane from 0 to 2 pi for which f of x is less than g of x? So this is similar to, actually, it's just a classic AP style question. Instead of giving you the inequality, they're asking you to set it up and then evaluate or solve for that inequality. So we know that f of x is 4 plus 2 cosine x, and g of x is going to be 3. So we have the inequality here. Again, we follow the same trend. We want to isolate the trig expression. So I'm going to subtract 4 from both sides. So I get negative 1. Divided by 2, we get cosine is less than or equal to negative 1/2. And this is a standard coordinate on the unit circle. So if I graph this, on the xy plane, we have our unit circle. And we are dealing with a non-inclusive inequality. So my previous examples, they were inclusive. So I use solid circles. For this one, I'm going to use open circles, just so I don't forget. So cosine x is less than or equal to negative 1/2. So now, unlike the previous example where we were dealing with sine, we were looking at the vertical relationship. We are now looking at the horizontal relationship. So as we travel to the right, x is getting more positive. As we travel to the left, x is becoming more negative. And the two angles that correspond with this are going to be here at 2 pi over 3 and here at 4 pi over 3. So theta is equal to 2 pi over 3, and in quadrant 3, theta is equal to 4 pi over 3. Now, the question is asking when will cosine x be less than, strictly less than negative 1/2. So now we're looking at this. This is when x is equal to negative 1/2, and we only want the portion of the unit circle where cosine x will be strictly less than negative 1/2. So that's going to be this portion over here. And it is non-inclusive. So we will not include those angles that we are restricted in between. So again, we're starting at 2 pi over 3. And it's going to be non-inclusive. I should have written x here, not theta. That's very bad. Yeah. So if they present you with x as the input, make sure you follow the variables that they give you. So this will be x, and then which is less than 4 pi over 3. And that's it. And then number 11 says let h of x equal 3 cosine x and let k of x equal root 3 plus cosine x. What are all the values of x in the xy plane, 0 to 2 pi, for which h of x is greater than k of x? So this is similar to the question above. So we have h of x, which is 3 cosine x, strictly greater than root 3 plus cosine x. And this one's going to be different because, okay, they're the same degree. They're like terms, so we can combine them. So I'm going to subtract cosine x from both sides. So I have 3 cosine x minus cosine x is greater than root 3. And I have 3 cosine x, and then I have 1 cosine x. So I'm left with 2 cosine x is greater than root 3. Divide both sides by 2, and we get root 3 over 2. Again, we lucked out. We have a standard coordinate on the unit circle. So I'm going to go ahead and sketch this out. And we're on the xy plane, and there we go. All right, so we're looking at the x coordinates again. So as we travel to the right, the x values will increase. As we travel to the left, the x values will decrease. And we are looking at root 3 over 2. So we'll be at theta equals pi over 6. Oops, x equals pi over 6. Sorry, that's my dog snoring in the background. And then x is also equal to 11 pi over 6. So we have a pretty special case here because we have to make sure that we're starting from 0 to 2 pi. So I'm going to initiate here. And then I'm going to travel counterclockwise and basically collect the intervals that will satisfy my inequality. So if I start here, I will go from 0 to pi over 6. My inequality is non-inclusive, so that means that pi over 6, it will not be included, but I will go up to pi over 6. And then anything else from pi over 6 all the way around to 11 pi over 6 will not be included. And then we're picking up more angles that satisfy this inequality from 11 pi over 6 to 2 pi. So we're starting and ending at the same place within this interval, but it has to be 2 separate intervals because we have to start from x is equal to 0. Stop writing theta. X equals 0. That's the starting point, and our finishing point is x equals 2 pi. So I'm going to write it out like this first. I'm going to have 0 is less than x, which is less than pi over 6. Now, this inequality means that we are not including pi over 6, but what about the 0? This 0 here, it's included within our domain restriction from the get-go, but how do we know whether to include it in our actual solution or not? If you're not sure, just plug it in. So if we plug in cosine of 0, and if we want to see whether or not that's greater than root 3 over 2, well, cosine of 0 is going to be 1, which is strictly greater than root 3 over 2. So we will include the 0 here. And then we have our second interval. So we have 11 pi over 6 is less than x, which is less than 2 pi. So again, 11 pi over 6 will not be included because of our inequality with h and k. But what about the 2 pi? Again, if you're not sure, plug it in. So I have cosine of 2 pi, and I want to know, is that going to be strictly greater than root 3 over 2? Well, cosine of 2 pi is going to be 1, which is greater than root 3 over 2, so we will include 2 pi. All right, this is essentially an introduction to inequalities, and then we will be doing inequalities using sign charts. Hope this helps.